Hey everybody, where we left off last time was we had these little wumpuses running around, we have coins, but we didn't implement collision detection. So my wumpuses will group together because they don't know how to detect if they're grouping together to stay separate. We don't know if I'm touching a wumpus, we don't know if I'm touching a coin. So that's what we're going to fix right now. Collision detection is tricky, particularly if you want pixel-perfect collision detection. So we're going to start off with a kind of an inaccurate but simple form, and then we can improve it later if we need to. The first thing I want you to notice is that all of our sprites, the coins, the wumpuses, the wizard, each of these sprites can be bounded by a rectangular shape. So the way we're going to do collision detection is we're going to ask, is the rectangle surrounding each of these sprites overlapping at all? The reason we're doing that is because it's relatively easy to test to see if rectangles are overlapping. Here's how you do it. So here are some very different looking rectangles. These two are overlapping, these two aren't. What you can do is compare the x-coordinates of one and the x-coordinates of the other. If you look at how they're projecting downwards, they make two different intervals. And then look at the y-coordinates of one and the y-coordinates of the other and project them, and that makes a different set of intervals. Two rectangles are overlapping if and only if both of the intervals of their x-coordinates and their y-coordinates are overlapping. So here you see they're overlapping in the x direction, but they're not overlapping in the y direction, and that's a signal that the two rectangles are not overlapping. Where here they're overlapping in both, and we see that they are, in fact, overlapping in both dimensions. So that's what we're going to do. We're going to make an R intervals overlapping method, and we're going to use that to test to see whether rectangles are overlapping. So entity is a natural place to do this, because I want any entity to be able to see whether it's overlapping with any other entity. So I'm going to call it is hitting, and then entity other. And I'm just going to return false for the moment. And then I said I wanted a helper method, which is going to be private. R intervals overlapping. And I'm going to have a low 1, and a high 1, and a low 2, and a high 2. So if we look at the picture, let's just look at the x interval. So low 1 would be this x-coordinate that corresponds to the left-hand side of here. High 1 would be the larger x-coordinate on the right-hand side of the object. Low 2 would be the left-hand side of this object. High 2 would be the right-hand side of this object. So low and high just refer to the smaller and the larger x-coordinates, and each pair of x-coordinates comes from the left and right-hand side of one of our images. So, so I guess now I got to figure out how can I tell if intervals are overlapping. Well, there's a bunch of different ways they could be overlapping. They could be inside each other. This one could be larger than this one, so they could be sort of inside each other the other way. They could be partially overlapping. It's much easier to test if two intervals are not overlapping, because there's only two ways that could happen. If interval 1 is smaller than interval 2, or if interval 2 is smaller than interval 1. So if one is entirely to the left or the right of the other one. So let's do this. If the high value of my first interval is smaller than the low value of my second interval, that implies that the low value of my first interval is also smaller. So it's like both low and high are smaller than the lowest of the second, so that must mean that the intervals are not overlapping, because both coordinates of the first interval are smaller than the lowest of the second. So I'll return false. I can also test the other way around. So if the high interval of the second is smaller than the low interval of the first, then I'll also return false. Otherwise, I'll return true, because if they are not non-overlapping, then they must be overlapping. I know that was all maybe a little bit hard to understand verbally, so I would really encourage you to sit down and sketch some pictures of what these two intervals look like, and make sure you really understand that step for why does this actually successfully test for whether or not the intervals overlap. Alright, so now for is hitting, all we need to do is run it twice. So if our intervals overlapping. So let's do the x direction first. So I've got my own x coordinate So get x is my left. Do I have a left-hand x? Let's see. Yeah, so left x is my small x, right x is my large x, and I'm comparing that interval to other.left x and other.right x. Alright, so if it's overlapping in the x intervals, and it's overlapping in my y intervals, so that will be this dot top y, this dot bottom y, other dot top y, and other dot bottom y. So if they're overlapping in both directions, then I'll return true because they're overlapping, otherwise I'll return false. And actually that pattern is unnecessary. I could really just return the result of that Boolean expression. Okay. What's happening? Okay. Cool. So now we should have a way of testing whether an entity is colliding with another entity. So let's add something that will test if the player is hitting coins, for example. So that should probably go in the levels tick. So I move the player, I move all the entities, I tick all the tiles, but now let's do run player collision detect. I think it's just nice to separate this out as its own method. Alright, so I'm going to loop over all the entities in my game and see if the player's hitting any of them. So entity E, what's my entity list called? Entity list. And then I'll say if player dot is hitting entity E, then let's handle the collision. So player dot handle collision with entity E. Alright, so now we gotta give it a way to handle the collisions, so I'll create that method. So I guess I want to test to see what kind of thing I'm colliding with. So I'm going to test if E is an instance of coin. And I'm only going to handle collisions with coins for right now. So right now I'm just going to do this, just to see if that's going to work. So let's go ahead and run this. And when I'm overlapping a coin, my console should be displaying I'm hitting a coin, and it is like mad. And then when I'm off the coin, it should stop. Great, so that's working. So last of all, I guess I want to collect the coin, but right now I don't have a way of removing coins from the world. So I would like to say something like this. Let's give my player a money variable. So money equals money plus E. Okay, well I can't do E.getValue because right now... Oh, Eclipse, you're so clever. So Eclipse has shown me what to do. E is an entity. Entities don't have a getValue method. I can't say E.getValue because that's not a thing. However, Eclipse knows that coin does, and so it's doing the downcasting for me. It's taking my variable E, it's casting it to be a coin. That's why the parentheses are here. It's doing that first. And then we're running getValue after that. Great. I don't have a money variable, so let's make one. Create field money, and let's make sure that it's doing something sensible up here. It's a private, it's an int, great, and so I'm going to put it in my constructor. I probably want getters and setters for it, but I'm not going to do that right now. Okay, so I've added the value of the coin, but now I need a way to remove the coin from the world. So here's what I'm going to do. I'm going to add a method inside all entities called markAsDead, which will set a new Boolean that will make it be dead, and then inside level we'll just check to see which entities are dead, and whichever ones are dead we'll remove them from the world. So in order to make this work, inside entity I'm going to add a new private Boolean isDead starts out as false. Now I need a mark as dead, and then is dead. I'm going to set it to be true. And now let's get a getter. So is dead will just return the value of is dead. So this will give us a way of checking to see if an object is dead. And then inside level, I want to remove all the dead objects. So that should probably happen inside tick, inside my entity loop. So before ticking it, I'm going to just check if it's dead. So if entity.isDead, then I don't want to tick, I want to remove it. Otherwise, I'll tick it. Alright, well the natural way to remove it here would be to do this. It would be to say entity list.remove entity. The problem is, if we do this, it's going to throw an exception called a concurrent list modification exception or something like that. And the idea is if you are iterating over a list using a for each loop, and you try and change the list while you're looping over it, it will throw this exception. So one way to fix this is we could loop over all of the entities separately down here. A second thing we could do is, instead of using a for each loop, I'm going to go to a regular for loop. So I equals 0, I is less than entity list dot size, and now we'll say entity equals entity list dot get I. So I'm getting the ith thing out of the list. And now I'm allowed to remove it, but remember, when you remove something from an array list, everything else slides down by 1. So if I remove this, what used to be an index I is gone, and now the thing that was in one index larger has slid down. But the problem is, when I get to the end of my for loop and I increment my index, now I'm at a larger index, and I've skipped the entity that got slid down into index I. So what I'm going to do is I'm going to say I minus minus here, so that way when I do I plus plus, it's like I'm visiting the same index twice, because I removed the thing that used to be there, and so now there's a new thing there, so I want to visit that index one more time. Alright. I think this should probably be good. Let's see if we can collect some coins. Cool. I have successfully collected the coin. Come back next time, and we will add turrets that shoot things.